Hello everybody, my name is Tye Milazzo, and today I will be talking to you about my water research, which is using chemical materials to desalinate contaminated water sources. I am under the guidance of Dr. Tengfei Luo in his monster lab. So before I go into my research, I would like to talk to you a bit about the world today and why I want to do what I do. Around the world, there has been a water shortage. There has been scarcity all around, but we can see that even in most developed areas, like in the United States, there has been a physical water shortage, which means that there's not enough water in the local area to give to all of its population and has to get imported from somewhere else. In my own home state, Colorado, we've been experiencing wildfires, droughts. The Colorado River has been getting drier each year to the point where we've actually begun seeing the bottom of the river, which is a very scary thing, as not only do us Colorado residents need that water, but the people above us and below us both use the Colorado River to help their own populations. So it's important that we start finding new water sources that weren't available to before, because without that, we are going to experience this even greater shortages, more wildfires, and more lives will be lost. So when I started looking into research into water, one thing that stood out to me was that it should be cyclic in some nature. Water, to purify water, we need energy, and a lot of energy needs clean water. So to keep this balance, I thought it'd be very important to find some sort of research that keeps this cyclical nature, which is when I found Tengfei's Monster Lab. Now, the Monster Lab stands for the Molecular Nanoscale Transport and Energy Research Laboratory, which brings together simulists, theoreticists, and experimentalists to look at and tackle common important issues that we see in today's society. And we all work together to help find solutions to these major problems. So, what I do is I work with several different departments. The first one I would like to talk about is the Chemistry and Biochemistry department, who helps us synthesize special chemicals that I will be using in a procedure I will be talking about soon. So these are some of the graphics of the different methods and organic synthesis that we have been using to make said chemicals, which is called an ionic liquid, or IL, which is a mix between two ions that come in a liquid form. Now, when I get these ILs from the biochemistry department, I will mix them with a water brine. And what happens is when we heat up that water brine and IL mixture, the water will get dissolved into the IL, but because of that ionic component, the IL will reject the ions that was found in the brine. This means that there is now pure water being dissolved in the IL, and it's rejecting that salt into the water that doesn't get resolved. So, when I take out that IL, and let it cool back down, we then get the water coming back out of solution and out of the IL. I can extract the IL and we will have pure water later. And this is a cyclical nature. So that means we still have IL left over. We lose very, very little of it using this procedure. And this is more energy effective than things like reverse osmosis or just evaporating and recondensing the water, because we only need to heat it up to 60 to maybe 75 degrees Celsius at most, which is much more energy effective and very helpful if you're looking at small scale desalination, especially if you're looking at underground desalination when you don't have the room to build large reverse osmosis machinery. Finally, I will work with the chemical engineering department to do simulations using different programs like LAMPS. This is to help not only verify my results that I find in the lab, but also to help create and expand a model so that we could test ILs before they have to actually get into my hands and go through a procedure. This will help increase efficiency, lower material costs, and is overall incredibly helpful. And one of the reasons I love this work is because it is incredibly interdisciplinary. I work in the material sciences group, which bring together chemists, engineers, physicists, and people from all across different fields to tackle these problems. And it is incredibly efficient. I don't think I could do a lot of what the chemistry department does. And I have also learned a lot from them. Same with the chemical engineering department. I had no idea how to do simulations before coming here, but now working with these departments on the same problem, I have actually gained these skills as well. So interdisciplinary work means that not only do we get to all use our strengths, we all learn from each other and build out our repertoire of knowledge. And I think that's incredibly interesting and incredibly helpful for future research. So, with all that said, thank you for caring.